Hey everyone, today we'll be covering permutations and combinations, but this video will mainly be focusing on permutations. We'll cover combinations in another video. So first of all, what are permutations and combinations? Combinations and permutations are just a part of combinatorics, which is figuring out how many combinations there are of certain scenarios. So let's start with permutations and combinations and the difference between them. So for example, take the word dogs. If we were asked to rearrange this into as many ways as possible, for permutations, let's say we had to arrange it in groups of 2 letters. We could do D-O, O-D, O-G, G-O. I'm not going to list all of them. But in permutations, this and this would count as different things. But in combinations, they are not counted as different things. Both of these are counted as one thing because in permutations, order matters, but in combinations, it doesn't. So as long as it had the same letters, it's still one combination. But is there an easier way to list out these things? Well, there's usually a formula we can use, because let's say we had to list out all groups of 2 for dogs for permutations. We'd have to do DO, OD, OG, GO, SG, GS, SD, DS. There's going to be a lot. So there's a formula. It's written as NPR, where N factorial is nothing but multiplying all the whole numbers to 1. So let's say 5 factorial, that's 5 times 4 times all the way to 1. Okay? So the formula goes like this: N factorial over N minus R factorial. So N is going to be the number of objects that we have in total, and R is going to be the amount that we're rearranging. So let's do this with a word problem. Okay, so in this example, how many ways are there to award first, second, and third? So let's draw them. Say first, second, and third to 5 people. So P, 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 and P. Well, we can just use our handy formula, which is N factorial over N minus R factorial. So our total number of things that we have here are 5, since our total number is 5 people. So 5 factorial over 5 minus, and then we're choosing 3 ways to award position. So 1, 2, 3, since it's first, second, and third. So minus 3. So this is just going to be 5 factorial over 2 factorial. So if we expand this, 5 times 4 times 3 times 2 times 1, and then 2 factorial is just 2. So we can cross out the 2's. 5 times 4 is 20, times 3 is 60, and we don't need to multiply by 1. So our answer is just going to be 60 ways for this problem. Okay, our next problem. How many ways to arrange the word lollipop? Okay, so for word rearrangement, we can't necessarily use the same formula we used before. So there's a new formula we can use, although it's similar. So the top, N factorial. The bottom is going to be a bit different. So let's say D1 factorial times D2 factorial dot all the way to D infinity factorial. So how does this formula work, or what does it actually mean? Well, we know what N factorial means. That's just going to be the total number of letters. But what does this D mean? Well, D1 is going to be a letter that repeats multiple times. So we're doing this bottom part to remove repetitions, right? Because even if it is permutations, let's say you arrange the word LOL. Even if you change around the L's, that's still going to be LOL. So even in a permutation, that's still counted as 1. So we need to remove the repetitions. So let's say D1 is L's. L is repeated 3 times, so we would do 3 factorial. Then our second repeated letter would be P. That's repeated twice, so 2 factorial. Then O, that's also repeated twice. And then finally L, so 2 factorial. So that's going to be the bottom side. Now top side, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 letters. So 8 factorial divided by 3 factorial times 2 factorial times 2 factorial times 2 factorial. So let's evaluate this. So 8 times 7 times 6 times 5 times 4 times 3 times 2, and we don't need to do times 1, over 3 times 2 times 1, that's 6 times 2 times 2 times 2. Okay, well, first of all, cross out the 6's, cross out a 2 and a 2. Well, now we can cross out these 2's for this 4. So our answer is going to be 8 times 7, 56, times 5, which is going to be 280. So we have 280 ways to arrange the word lollipop. Okay, this is going to be our last problem and by far the hardest. 8 people are seated at a political party dinner table. How many ways can they sit if the president and secretary have to be seated together? Okay, so this is our first problem with constraints. So how do we deal with this? Well, the first thing is that we sometimes have to abandon the formula. That's the key idea. And we have to start using logic, especially with combinations and permutations. So let's draw this out. That helps a lot. So let's say P, S, and then the other people are just, random squares. We don't care about who they are. So 8 people. Okay? But since the president and secretary have to be seated together, we can just make them one group, right? They count as like one thing. So we can cross this out and redraw this as this. So now, let's say we fix now we only have 7 objects, right? 1, 2, 3, 4, 5, 6, 7. So this just means 7 factorial ways to arrange this. But wait, we're not done. The president and the secretary can be swapped. So they can also be arranged like secretary and president. So this multiplies everything by 2. So our answer is just going to be 7 factorial times 2. And to get the real number, you can just plug it into the calculator. Okay, that's all for this video. And I hope you understand the difference between permutations and combinations, as well as how to solve permutations with the formula and using logic and constraints. I'll link a few practice problems in the description below, and I'm looking forward to my next video over combinations. See you there.